Hello, everybody. My name is Iskander Usanov. I'm from company Photonics, and today I would like to tell you more about our company, about our products, and special focus will be on the multispectral fiber sensors for biomedical and industrial applications. Just a few words about our company. We're already more than 20 years in fiber photonics. We're based in Germany, in beautiful city of Berlin. So we are researching, developing, and producing specialty fiber products for broad spectrum range from UV silica fibers starting from 300, 200 nanometers up to special infrared fibers and hollow waveguides. And they span up to 16 microns. So we have this unique technology of full cycle production of polycrystalline mid-infrared fibers and special hollow waveguides. And we also provide products and special silica fibers with metal coatings, with aluminum and copper metal coatings. We're also doing a special fiber optic probes, customized probes, standard probes for medical and industrial applications, and especially for process control, for PAC, for process optimization, PAT, sorry. And we also make a volume production of different fiber optical products for medical industrial applications, for industrial lasers, and we are doing many different probes and also special accessories for fiber optics like couplers, special couplers for different spectrometers, and so on. And today I would like to also tell you more about our special development of multispectral fiber systems. We really started about 5-6 years ago when we started a special our project called fiber optic molecular sensor. And it was based on the modular diagnostic device, modular system that includes Raman, Fourier transform, infrared spectroscopy, near-infrared spectroscopy, and fluorescence. And all these techniques are combined using different fiber optic cables together or separately in one probe or not in one probe. And it's also you can also couple their laser for therapy. Yes, at near infrared or mid-infrared, for example, CO2 laser. And this system enables to use these K-spectroscopic methods to achieve a very good sensitivity, yes, and precise parameters for direct online diagnostics and online therapy. And the main advantage of this system so that you can really combine all 4 methods and you can choose for your specific applications which method would be better, would give you a synergy effect. And I will tell you more about this synergy effect in the next slides. So, and actually here on the left side, you can see how it really looks like. So when we are combining really very compact spectrometers in one probe or in several probes, and then we make a special analysis and see how it really looks like. And for example, here is a combination of near-infrared and near-infrared data. So using our special attenuated total reflections probe for near-infrared and probes based on silica fibers for near-infrared. So and we made a lot of tests on tumor samples, yes, and we see that, for example, glucose role as a biomarker in this kidney tumor, while lipid and water ratio can be detected by near-infrared reflection probes, and it's also like biomarker. And when you really fuse all this data, all near-infrared and mid-infrared data together, then you can get a synergy effect of 15% increased accuracy, and we show it, and we in our paper. And you, if you want, I can send you later on the paper also. The next example is the combination of mid-infrared and fluorescence data. So if you are using these 2 techniques separately, you will not see this very good separation using principal component analysis. But when you really fuse the data together, here it's really two separate probes. But later I will show you how it could be combined. So when you really fuse the data together, then you can see the full separation of these two techniques. And we also presented the data in Sensors magazine. I can also send you a link to this paper. The next example is a combination of near infrared and fluorescence data. Fluorescence especially for tumor detection, fluorescence from our point of view is one of the key spectroscopic methods, because for normal tissue it's really always high fluorescence, while for different cancerous tissue it's always drops. So when you are measuring Raman and fluorescence, you can always see it. So but when you combine this data, fluorescence and also together with near infrared, you can already see that accuracy of discrimination for cancer tissue and normal tissue can go up to 99%. Of course, it depends on the pre-processing of your data, on the modeling, how you do it. But if you do the same modeling pre-processing just on the separate data sets, then then the results would be worse. So here we presented a Combi probe for mid-infrared and fluorescent spectroscopy, but it also could be combined near-infrared spectroscopy, because this probe based on the mid-infrared fibers. In this example, it's chalcogenate fibers and silica fibers together in one probe head. And for mid-infrared, it is based on the ATR, attenuated total reflection. So for silica fibers, near infrared or fluorescence is just reflection spectroscopy or fluorescence spectroscopy. Yes, and we tested this probe on different biotissues. It was different tissues of chicken, like fats, fatty tissue, skin tissue, muscle tissue. And you can see when you are using mid-infrared separately or fluorescence separately, you cannot really distinguish some types of the tissue. But when you combine the data together and using this multivariate analysis, yes, here it's a principal component analysis, you can really distinguish each type of the tissue from each other. And in this case, we believe that it will also work for not only for different tissue types, but also for diseases like tumor. Yes, using such a probe, you can make this inside the human body. Yes, for colorectal measurements, for using some endoscopes. And during these experiments, when we made these experiments, we also find out that you can even get a full separation of different types of tissue using only two variables. Yes, only 630 nanometers for fluorescence and yes, 7043 wave numbers, yes, for mid-infrared. And using such a probe, we can really build a sensor system based on only LEDs and quantum cascade laser, for example. Yes, and here I also wanted to present you our unique probe for Raman and near-infrared diffuse reflections. So these two channels, they can really work simultaneously. The stray light in the diffuse reflection spectroscopy channel is less than 1%. It's very important for such an applications. For example, in pharma applications, the shaft is specially heated, so there would be any condensations on the windows of it. Yes, and this probe is really made for industrial applications. So thank you very much. I hope you enjoy it. If you have any questions, please call us or go to our booth, or you can also chat with our sales manager, Mikhail Merkan. Thank you.